everyone. My name is Jean Chung, and I'm here to talk to you about Firebase. My hope today is to give you a general sense of all the different things that Firebase has to offer you as a developer, as well as give you some things to consider if you want to try using Firebase for an app. First of all, if you haven't heard of it before, Firebase is an app development platform that was acquired by Google. They offer support for both web apps and mobile apps, and you can log in with your Google account, and configuration is pretty straightforward. They offer things like authentication, a database, file storage where you can store image files and audio files, as well as hosting and deployment. So let's actually start with the database, because there's a lot I want to cover. Firebase's database is a NoSQL database, so it's not relational, which is what we've been using mostly on the back end, which means all the data are not stored in tables, but rather in JSON objects in a tree. So here's an example of some sample data as it would look in a table. And here's how you might convert it instead to a JSON object. So you can see I took the user IDs and made those the keys for the user objects in the tree. This is often going to be useful for you in the database when you're working with a lot of user data. And just because you haven't used NoSQL before doesn't mean you're learning something completely new, because this is probably similar to the way that a lot of you are used to using data in your Redux stores, storing objects containing a variety of things, including other objects. I just want to talk about structuring the database very briefly. So this is something that's come up a couple times in the last few days, but when you're working with a database like this, it's really easy to fall into the trap of nesting several branches deep just because you can, especially if that's how the data are related to each other. So for example here, we're nesting Ron's pets under his user object, and then each of those pets has their own little object. But this can be a bad idea for a lot of reasons. Just one example is that when you're getting the data for one branch, you're getting the data for all of the child nodes. So if you just wanted to get a list of all of the users' names in your database, then you'd be pulling up all of their pet information every time. Before we move on, you might have noticed that there's like random strings of gibberish embedded in this little database, and we'll get back to that in a bit. So instead of nesting the data, one thing you can do is take out an object and make that another branch in and of itself. So here we've made another branch off of the root for pets. And you can see the user's branch is collapsed right now. But just as before, we were using the user ID. So if we opened up one there under users, we would see the user object for that user. And then in the pets branch over here, we're also using the user IDs as the keys to that branch. So in this case, 3 was Ron's user ID. So under pets, if we go to 3, we can see Ron's pets. And then under users, if we go to 3, we can see Ron's user object. So now let's talk about how to actually work with data in Firebase. Firebase provides routes for you to use in accessing all your data. It's actually pretty straightforward. So because we're using the database, we're going to access it by doing firebase.database. And then in the .ref, that's where you put the route or the path. So in this case, if you just wanted to get the entire user's branch, you would just put users. Or if you wanted to get a specific user's branch or node from inside of users, you would just do users/2. So in the case of Harry, that's what we would do. And the reason for that is just because that's the way we decided to structure the database, by using the user IDs as the keys. If we had instead decided to use the user's usernames as the keys, then you would, for Harry, navigate to users/thechosen1. So here's an example of how you might write to the database. I'll just walk through the code line by line. So first, you want to import Firebase from Firebase. Because we have configured our own our Firebase project elsewhere in the app, when you're doing this, it's not just like requiring a node module. When you require Firebase like this or import it, it actually has your project information. So this is a function that I wrote to add one user to the database. based on information that they gave us when they're logged in. So in the first line of the function, we call firebase.auth. And from that, we can destructure out who the current user is that is currently logged in, because they're the ones that filled out the form and sent us their information to add to the database. And then here with firebase.database.ref, that's where we put the path. So in this case, we're going to the users branch, and then taking the current user that we destructured out, we're getting their user ID and placing their data there. Then .set is a method for adding information, writing to the database, and we're sending all the information in an object. That returns a promise, so you can .then off of it and then do whatever you want. In this case, I'm dispatching an action. One cool thing to note is that Firebase's database using NoSQL is different from like SQL and SQLize in that you don't have to do all of like the creating schemas and setting up the tables and making sure they're all there in the right way and then send your data. You can just kind of start writing to it. So if this is the first piece of information that I'm adding to the database and no user's branch exists, writing this line of code will create the user's branch and will dynamically also create that place in the database that has user ID 2 as a branch, or whatever user ID we passed in. So this is kind of a double-edged sword in terms of flexibility, because while it is more flexible and you can do things on the fly without having to do too much legwork in terms of like models and schemas on the, when you're first starting out, there's also a great potential for inconsistency. So I could send one user object to my user's branch with an ID of 1 that has these properties, first name, last name, username, and status, and then I could send another user object with an ID of 2 that just has like favorite karaoke song, and that's it. So there can be a lot of inconsistency. There's no, you're not going to have like a not null constraint. So that's just something you have to keep in mind and make sure that you're being very consistent when you implement it. Oh, one thing, so .set and .push are both methods for writing to the database. .set will overwrite any existing data and will use the key that you determine in the path. So right now we're doing /user ID, and that becomes the key for that user object. .push won't overwrite anything. It'll just push something else to that location, and it'll set its own key. And we'll actually get back to that in a sec, so it makes more sense. And then it also has methods for updating and removing from the database. So we noticed earlier that there was gibberish, and this actually has to do with the difference between .set and .push. So with .set, because we're overwriting all the information that's at a given location, then we can set our own key. Because anytime we send one piece of information, that's all that's going to exist at that one key, our key being 1. But when we .push, we can send lots of different kinds of information at different times, and they'll all get stored there. So what Firebase does is it generates a random string. It's actually not random. It has to do with when you sent it. But a random-looking string, and set that as the key. So that's just something to keep in mind when you're accessing things and when you're trying to abstract the data out that you want. It's like one more layer deep that you have to go in to get what you want. Let's see. So as I said, Firebase also provides features for authentication. You can have people sign up and sign in with their emails and passwords, and Firebase handles a lot of the legwork for you, like validating the email, hashing the password, storing it, making sure when someone signs up, tries to sign up, and that email already exists, then it'll send back a specific error message about that. And so you can do all that in your .catch. And they also offer login with Google and Facebook and Twitter and GitHub, which is pretty awesome. As I said earlier, they also have storage. So you can store images, audio, and video, and it's really awesome for storing any user-generated content. So for example, over break when I was learning React Native, I used Firebase storage for the mobile app that I built so that when one user recorded an audio file, they could send it to another user, and that audio file is actually just stored on Firebase's database, or in their storage. And Firebase also offers deployment. So they make it very simple. You can just deploy in a few lines of code on your command line. But it is different from Heroku. So they're limited in running server-side code, so we can't like run node scripts on their servers. So if you need to do that, even when you're using Firebase's database, then something like Heroku would probably better serve your needs. And if you want to learn more, the Firebase docs are actually really useful and well-written. And they also offer a quick start repository where they have sample code for all the different pieces of the database, or of the feature, including the database and authentication and all that. So you can download that, try it out, just modify it with how you want to do it, and kind of use that as a jumping off point. So yeah, I hope that was helpful to you, and that you'll try using Firebase.